Hi, everyone, and welcome to the Texas State Data Analytics Club Introduction to Python series. So, as we move through, we're going to be going through pretty much the entire data analysis process and how we can use Python to address each of those steps. But first, let's talk a little bit about Python itself so that we have a good idea as to how it works and how it can be used. So Python is really one of the most versatile programming languages that we have right now because it can be used for anything from software development to data analysis to websites. Basically anything that you can think of that you would need to code for, Python can probably do. So here we'll talk a little bit about how Python is actually used for data analysis, show you an example, and teach you some of the basics of the language, especially as it pertains to data analysis. So before we get too much further into it, let's talk about the data analysis process and then talk about how Python ties into that. So, data analysis generally follows a 6-point structure. You start by defining whatever thing you want to answer with the data. You start by collecting the data that you're going to use to answer your question or questions. Then you prepare the data for the analysis itself. You do some very basic statistical summaries and visualizations so that you understand the data a bit better. And then you start performing much deeper analysis, and that can be done with things like machine learning, statistical models, and various other things. And finally, you actually present the findings of your analysis because by now you should have answered all of your problem statements, and you can create some visualizations and get everything ready to present to whoever needs to know the results of your analysis. And Python can be used for all four of these final points. You'll have to excuse me, my Jupyter notebook can be a little bit finicky, probably a mouse issue, really. Anyway, we can do all of that. We can make sure that the data is clean, do all kinds of analysis, create visualizations, basically everything you would need to do. And to showcase this, let's show an example project. So, as a brief introduction, we did a competition wherein we looked at the Google Play Store's app reviews, and we tried to see if an app developer should direct their efforts toward making a specific kind of app by basically seeing how app categories correlated to things like review counts, the review score, how many downloads something got, and other key metrics like that. So, I'll walk through this briefly, but here we use Python for pretty much the entire process. So of course we got all the data loaded in, we got everything cleaned, and by the time we got to the end of the analysis, I'll show you, we did a correlation matrix, basically to see if any of these app categories correlated with either rating or install count. And we did this on a bunch of different columns and metrics also. But the key takeaway is that there really weren't very many strong relationships, but it was still possible to perform all of this in Python, and much more complicated analysis can be done in this program as well. So it is very versatile and very powerful for data analysis. And this project kind of goes to show that. So moving back to the main document, Python really can be used for answering tons of different business and research questions, as we kind of touched on. Like one thing that I've personally done is forecast the number of COVID cases that will occur in 2024. Of course, this is being recorded in 2024, but I performed the analysis in 2023. But I got to see all of that. I've also done things where I've applied pretty advanced machine learning and statistical models to understand data at a very deep level, predict the future, understand the structure of data very well, and answer pretty complicated business questions. So it really is quite powerful for both research and for for business problems. So, moving on, we'll talk about the basics of Python itself. And we'll start with base Python and move towards one crucial package, which is called pandas. And I'll explain a little bit more about what a package is in a second. So first, how do you actually use it? So this video won't go through how to install it or the preferred way of using it or anything, but personally, I like to use Jupyter Notebook through Anaconda, and you can find out ways as to how to install it and how to use it if you look up Python IDEs, because there are plenty of different ways to use Python. Again, I prefer the Jupyter Notebook, but it doesn't really matter what you use. So, probably the first thing that any Python tutorial will tell you to do is how to print hello world, because it's kind of a staple of the language. But printing itself is basically a way to show the results of an analysis or to print anything. And basically what printing is, I'll show you whenever I run this code cell, is it will produce text, at least in some form, or an image of whatever you put into the print statement. And this is helpful for really advanced calculations and for large functions where you wouldn't be able to understand what the output is going to be beforehand. So like if I put in like what is the square root of 2,894 and I put that into a print statement, it would tell me what the answer to that is and I wouldn't have to calculate it. So here's another example where we're talking about putting equations into a print statement. So here, pretty basic, 2 plus 2, and we assign that to a variable. And we say, if we print the variable x, we will get the results of this upper calculation. So this shows just how powerful it can be because while this is basic, it can be used for, say, showing off a data visualization that you made in Python. You could use all of your code to actually make the visualization, and at the end of it, put print visualization, and it'll show it off for you. And you'll be able to save that and share it with everybody else. And it can also be used for machine learning and stats outputs, and plenty of other things. So it is pretty essential to the language. So what else can Python do natively? So Python can perform pretty complicated math. The only thing to note whenever we're going through the symbols used for each operator is that the power symbol isn't exactly what you would expect it to be. It's a double asterisk instead of a caret. And we can perform very complicated math also. This is pretty simple, but it gets infinitely more complex than this if you chain together a bunch of equations or if you have a package that's capable of doing advanced mathematics. For example, here I calculated the square root of 49 and put that into a print statement. I had to import the math package to do this, and I'll explain more of what that means in a second. But basically, here's how it works. This F at the beginning of the print statement allows me to put code directly into the print statement. So as we saw above here, we had to assign the equation to a variable and then print the variable. Whereas here we can just say F, what we want to start with, and then make some curly brackets and put our code inside of that. And whenever we run that, it'll show that entire line as well as the result of this formula. So here, the square root of 49 is 7. Of course, that's correct, so the code worked properly. Now, data structures in Python. There are really 3 main data structures that people can look at, and these are dictionaries, lists, and tuples. While you may not engage with these directly too terribly often, they come up enough that it's helpful to know what they are, and they do form the bedrock for a lot of packages that you'll be working with later. So it is important to understand them. So first, let's get into dictionaries. So dictionaries are pretty important because they're often how data gets loaded into Jupyter into Python in the first place. And they're very similar to real-world dictionaries. Basically, you have one term, which is known as a key, and a definition which is known as a value. So you have a key-value pair. So for instance here, we're looking at the capital cities of the state of Texas and the state of California. So we have the key, Texas, paired with the value of Austin. Likewise, the value of California the key California paired with the value Sacramento. And we can call upon these dictionaries to see the result of basically to find a given value in a dictionary. So here I called upon capitals and I wanted to get the value for Texas, which of course is Austin. Now lists are pretty similar to dictionaries, except that there isn't any pairing of terms going on. There's only one term per entry. Now, these you probably won't deal with directly too often unless you need to make a list for comparison reasons, but they do come up somewhat often whenever you are adjusting machine learning models and statistical models. So it is important to understand what these are. So here, let's say we want a list of dog breeds, Dachshund, Greyhound, and Chihuahua. We assign that to dogs. And just to make sure that the list was created properly, we can do a print statement and it shows it off. So to make a list, you do have to assign it to a variable, and it's instantiated by using square brackets, as you can see there. So just to recap, the dictionaries are done by doing these curly brackets. You start with your key, use a colon, and then put your value. And then for every entry that you want to put in the dictionary, you separate it with a comma. And it's a similar thing for lists. Again, instantiated with square brackets, you put the term you want in there and a comma to separate them out. And these lists and dictionaries can be infinitely long, which is why Python is so good at working with large data sets. And now tuples are very similar to lists once more, but the key difference is that you can alter a list using code later on, whereas with a tuple, if you want to alter a tuple, you basically have to reassign the variable or go back to the original code, adjust it, and then run all of your code again. So basically, if I wanted to change Dachshund in this list with a new line of code later on, I could. Whereas with tuples, I would have to make a new tuple or alter the original tuple. So a list can be changed and a tuple cannot. So tuples are instantiated with parentheses. And you can see here that we don't necessarily have to put text in dictionaries, lists, or tuples. You can put numbers as well. And here, just to make sure it worked, I'm going to print my tuple of numbers. And 1, 2, 3, perfect. Now, one very important part of Python is that you can define custom functions. And you can even import functions that other people have made. And this just makes things a lot easier because it means that you don't have to do the same function over and over and over and rewrite your code. You can just write out your code once and then call on that function for anything that you want to see. So I'll show you in this code cell what I mean by that. So here, I specify that I want to define a function. I have the title of the function, parentheses, and then however many values I want the custom function to take in. So here, this is pretty basic addition with two values, and I say I want it to return the sum of these two variables, a and b. So if I say print plus 3 and 4, so a has been 3 and b is 4, then that will give me the value of 7. And I can change these variables at any time. So say I want to see 4 and 4, and that would give us 8. So this is powerful because if you have a very large and complicated function and you have to perform it over multiple data sets, you can simply define the function once, and then call upon this smaller function every time you load in a new data set. And that just saves you a lot of time because it saves you from having to write out the entire function every time that you load in a new data set. And this really just saves you quite a bit of time. And now for loops they come up somewhat often whenever you are defining functions. And it is important to understand them, especially if you're doing a lot of custom code. So here, basically a for loop will perform an action on every entry in a data structure. So let's look at what this looks like, basically. Let's say we have a list of numbers 2, 4, 6, 8, 10 assigned to here. I want to say that for every value x, every value in this numbers list, so it'll happen to 2, it'll happen to 4, it'll happen to 6, it'll happen to 8, and finally happen to 10. I want to print the square of x is x to the power of 2. So basically what this is going to do is iterate over this entire list. So it'll print the square of 2 is 2 to the power of 2, and then it'll move on to the next value. So the square of 4 is 4 to the power of 2, whatever the end calculation for that is. And it'll iterate through the entire list. And again, this list could be infinitely long, and this can work on other data structures as well. So let's see what the output of this looks like. It's going to take the square of all of these 5 values, and it will print square root of 2 is 4, 16, 36, 64, and 100, exactly what we would expect. And this is very powerful if you had to perform an action on multiple data points, because it just saves you a lot of time instead of having to say, oh, I want to calculate this for 2, and then saying, oh, now I want to calculate this for 4. You can just use this for loop instead. Now, here's the word that's kept coming up but that we haven't talked too much about yet, and those are packages. So a package, also known as a library, is basically an add-on to Python that somebody else has created. And these add-ons basically contain a ton of those custom functions that we talked about earlier. So these packages contained all these functions that other people have created, and now, because you've imported a package, you can use other people's code to work through advanced calculations, to visualize things, to implement machine learning and stats models, and do tons of other things in Python. And the fact that there are so many packages, and the fact that packages are so well documented, is one of the main reasons why Python is so commonly used for data analysis and data science. So we're only going to look at pandas right now, but data analysts will often use these packages. Pandas is for data analysis, as is NumPy, And matplotlib and seaborn are for visualization. And finally, you have scikit, which is a lot more machine learning and statistical model oriented. So pandas is really the most crucial one because it allows you to load your data in and it allows you to do a lot of exploratory analysis, which, as you might recall, is basically just doing statistical summaries and very basic ones at that, but they're still very helpful. And it also allows you to do some basic data visualization and work with much larger data sets than you could with Excel or other programs. So, if you have too large of an Excel file, Excel is not going to be able to open it up. And it's not going to be able to perform analysis, or if it is, it'll be very, very slow. But Python is able to handle these large amounts of data very efficiently. And it can deal with larger data sets than Excel is natively able to do. So that's why pandas and Python are so commonly used, as well as the abundance of packages like I've referenced before. But pandas is important to Python because it allows us to load data into Python, and it also allows us to generate some basic stats and do basic data visualizations. So it's really good for understanding the basics of your data and getting your data into Python in the first place. So let's look at loading in a data set and some of the very basics as to what this package can do. So you may have to install pandas if you don't have it already. But if you do, the syntax for any package that you want to install will usually start with import package. And if you want to rename the package, you can say as and then whatever you want to call it. The reason you might want to rename a package is basically to save time while typing. So here you see PD is standing for pandas, and here I typed in PD. If I did not rename it, I would have had to type pandas down here. So you could also import specific commands and specific bodies of commands from a package. And if you wanted to do that, you can do from package, which basically helps specify that you want to get a subset of the package and not the entire package. But for now, let's just focus on importing entire packages. So here we actually load in a data frame that is on my desktop. So here, I will store the data frame in a variable called df, of course, an abbreviation for data frame. I call upon the pandas package, and then I specify that I want to use the command read CSV. What this allows us to do is to basically take a CSV from a given file location and load it into Python. And this data frame in reality is like a strange mixture of dictionaries, of lists, and of tuples. But this makes it a lot more user-friendly, and it even allows you to show the data as a collection of cells and columns, or rows and columns. And this R in the beginning is really helpful because it allows you to load in data more efficiently. And oftentimes, if you don't include the R, it simply will not work. So this R is pretty crucial. So let's load it in the data frame. And that's done. And now we're going to look at the top 5 rows of the data set just to show you what it looks like, and we have a better idea as to what this data is. As you can see, this is not anything like the lists that we've printed or the dictionaries that we printed. This is effectively a standard spreadsheet, except that it can be a lot larger, and it typically, and it's just easier to work with in general. Now, this data set is for a fictional taxi company, and it's talking about like when people were picked up, when they were dropped off, how many passengers they had, etc. But here, because we have this head function, we can see the top 5 rows of the data, and we can see it for every single column as well. Now, if you have a huge number of columns, it might put an ellipses somewhere in the middle, because it does have a limit as to how many columns it can show. But in general, the head function works pretty well. And so, one more thing that we can do here is generate descriptive statistics for any column that has numeric data in it, like this passenger count, for example. So if I were to run this df describe, all of these columns have numeric data in them, and it provides some crucial statistics that are going to be of great interest to you because they'll help you identify a ton of different things about the data itself. So for instance, let's look at trip distance. So we see count 22,699. That's simply how many trips were recorded. We have the mean trip distance, which is about 3 miles, the standard deviation of trip distances, which is about 3.7 miles. We have the minimum trip distance, which is 0, which could be a cancellation, but it might also not be. So in cases like this, where you're working with real data, it's always best to contact whoever gave you the data to make sure that that is a valid value. You see the 25th percentile here was about 1 mile. The 50th was about 1.6 miles. The 75th was about 3 miles. But the maximum trip was about 34 miles. And you can see that that's a pretty substantial jump from this 75th percentile. So this may need to be addressed because this can affect our mean and our standard deviation quite a bit. And think of it like this. If we have, say, a series of incomes, then normally you see quite a few towards, say, the beginning of the distribution, towards the lower income values, but then it just keeps going and going and going. And you have a lot of values that are significantly higher than where most of them are. And if we use a mean, it'll basically go a little bit further to one side than where we expect the actual middle and most common values to be. So removing outliers, like those extremely high income earnings, is important to making sure that your analysis is accurate. And now, another thing that Pandas is capable of doing is scatter plots and other data visualizations. So here I'm going to do a scatter plots to see if there's any correlation between the number of passengers in a given taxi ride and the amounts that somebody paid for in the taxi ride. So here we go. If I run this cell, we see that pretty much everything is here in this like 0 to 100 range or so, 0 to 75. So it doesn't change that much depending on the passenger count. So that's probably not being taken into consideration for the taxi fare. However, one thing that we do see is that there are some pretty extreme outliers, especially in 1 and 2, because we see here somebody managed to pay negative money for their taxi service. So that's definitely not accurate. And we also have somebody that managed to pay $1,000, so they're way above what everybody else is paying. So those probably need to be removed, assuming that there aren't more than one. And also similarly here at about like 475 for a two-passenger count. But this helps you to basically see if there is a correlation. Here it's pretty much just flat, so there is some, but not much. But that gives you an idea as to what Pandas is capable of. But these other packages that we referenced can do quite a bit more. So NumPy does a lot of the stuff that Pandas does and a little bit more. Matplotlib and Seaborn allow you to do much more advanced visualizations than you can do with Pandas natively. So for instance, there are different types of graphs that you can plot with either of these, and Seaborn allows you to take the output of machine learning and stats models and visualize those much more efficiently than you could with, say, Matplotlib or with Pandas. And finally, there's Scikit, which is a lot more for machine learning, which can be used to simulate advanced scenarios that might be happening in the future. So for instance, say, I know that like 50 cars go across a specific exit in a 10-minute window on I-35. I can predict how many of those are red by running a simulation, which can be done using machine learning. And there are also things like forecasting what's going to happen in the future, say the number of new COVID cases, and you can perform advanced statistical testing using statistical models. And so Scikit really helps us to do a lot of that kind of stuff. And you can get extremely complex with any of these things. In fact, you can even use machine learning to classify text. So for instance, say that you have a bunch of IT tickets, but there's not really a good organization system for them. You can use machine learning to find out how many of those are related to different programs that the tickets are relevant to. So say like if it's Adobe and you have a ton of different IT tickets, you could classify them based on, say, whether they are for Photoshop, whether they're for Illustrator, for Lightroom, or for any of their other programs. And that can be helpful information to know. But anyway, that is just a couple of examples as to how Python can be used for data analysis, as well as its packages, and of course a brief introduction to the language, and one of the most crucial packages that data analysts will use within Python. So, if you have any questions about anything, please feel free to leave that in the comments. I will be sharing this code file so that y'all will be able to access that at any time. But anyway, thank you all for watching. I hope you learned a little bit about Python and a lot of its add-ons. And take care.